This is number 1 on Unit 0, Worksheet 5. We have a pendulum is held up to your nose. When it is released, it swings away from your nose and then returns. So, I think first, in order to have an isolated system, we're going to have to include the pendulum, the earth, and the surrounding air. I'm going to put my ZRL at the lowest point of this pendulum, which is right about there. That's not the color that I wanted though. Sorry. Right about there, we'll put our ZRL. This is my zero reference level where the gravitational energy will equal to 0. And then I want to talk about what changes. As you watch this thing swing back and forth, you can see that the height of the pendulum changes. And that's going to go with the gravitational energy account. You can see there's no arrow under the pendulum at A, there's an arrow at B, there's no arrow at C, there's an arrow at D. So what that arrow is telling me is that the speed of the pendulum is changing. If you can imagine this pendulum swinging back and forth. And that's going to be the kinetic energy account. And really, that's about it. Some of you guys are probably thinking maybe we have to include thermal energy. Probably if you imagine that this pendulum at some point in time is going to stop swinging back and forth. And you're absolutely right that as this thing goes, energy is going to end up in the thermal energy account. In other words, the system's going to get hotter, probably from maybe some air resistance, or maybe up here at the very tippy top of the pendulum, where it's connected to the ceiling, it's going to rub a little bit and make some noise, and some of the energy will go to the thermal account there as things get hotter. But let's just imagine you're only swinging back and forth a couple times, and so we can ignore that thermal energy by saying, you know, it's probably such a small amount that we're not going to be able to draw a block for it without the block being too big proportionally for the system. And so that makes this fairly easy. We only have 2 accounts that we have to worry about: the gravitational energy account and the kinetic energy account. So I'll put these in all of my little drawings. Oops. Gravitational energy, kinetic energy. Okay. And now we're just talking about our block. So at A, the ball is as high above the ZRL as it's going to be, so the gravitational energy will be large. It's not moving, and so the kinetic energy will be small. And so I will draw some kind of bar graphy thing here. Half of this game is playing with there we go. And no kinetic energy. And then at B, there is no gravitational energy because the ball is at the ZRL. Because we have chosen to have 1, 2, 3, 4, 5, 6 blocks of gravitational energy at A, if there's no gravitational energy at B, that means there must be 6 blocks of kinetic energy at B. It'd be cool if you could copy and paste this, but I'm not sure how that's going to work, so we'll just draw ourselves another box. Okay. And then at C, we're on the other side again. I don't know if you can tell this or not, but A and C look pretty much the same as far as the height of the ball, because now you're all the way at the other side. So C, because the ball is the same height as it is at A, the gravitational energy will be the same as it is A. And so we'll draw ourselves the same kind of six-bar graph at C. And then at D we have the first weird one. You can see that the ball is not at the ZRL. It's a little bit higher than the ZRL, and it's also moving a little bit. So we're going to have a little bit of energy in both of those accounts. There'll be some energy in the gravitational energy account and some in the kinetic energy account. It doesn't matter which one's which. Oops, let me fix this a little bit. Okay. It doesn't matter if you have, 2 in one, 4 in the other, 3 in one, 3 in the other, 1 in one, 5 in the other, as long as the total number is the same as the number of blocks you have at A. So I'm just going to draw this as the worst possible. There we go. I'm going to draw this as, I guess, 1, 2, 3, 4 in the gravitational account and 2 in the kinetic energy account. And then lastly at E, again the ball's way back all the way up to your face again, and we'll have the ball is not moving, so there is no energy in the kinetic energy account, but the ball is high above the ZRL, same height as A, same height as C, and so we should have the same amount of gravitational energy that we have in A and C. Now the question, if you want to think about how this system or how this analysis will change with the addition of thermal energy, then you have to kind of imagine what that's going to mean in terms of how fast the ball is going to be moving at B or at D, or how high the ball is at E and C.